Hello everyone, welcome back to the channel. In this video, we're going to talk about some exponential growth and decay models. So if we have a quantity that increases or decreases by a fixed percent each year, or maybe some other time period, then the amount y of this quantity after t years can be modeled by one of these equations. If we are growing, then we look at exponential growth, which would be y equals a times 1 plus r to the t power. And then if we have exponential decay, same exact equation, but instead of 1 plus r, we have 1 minus r. So what do these variables represent? Well, we just said that y is the amount that the quantity is going to increase or decrease. T represents our time in years. A is our initial amount. What are we starting with? How much are we starting with? The value of the car or the initial population, whatever we're trying to figure out. And then r is our percent decrease or increase, and that is written as a decimal. So that's going to be percent increase if we have exponential growth, and it's going to be percent decrease if we have exponential decay. And so to kind of distinguish, we see a growth factor as something that's going to be greater than 1 because we're adding our percent increase to 1, so 1 plus a decimal. And then our decay factor is when we're going to have a decimal that's between 0 and 1, so we're subtracting from 1 whatever our percent decrease was. So we're going to look at two examples, one where we see exponential decay and one where we see exponential growth, and we'll write a model for each one. So number one says the value of a car y in thousands of dollars can be approximated by the model y equals 31 times 0.92 to the t, where t is the number of years since the car was new. So part A says, does the model represent growth or decay? So to figure this out, we want to look at the value inside the parentheses. And notice how this is less than 1. So now this is going to be a decay factor. So the decay factor is 0.92. And so that means that, if we had 1 minus something in there, that's going to lead us into part B. So when we subtract something from 1, what do we subtract from 1 to get 0.92? Well, you would subtract 0.08, right? Because we do 1 minus that would be 0.92. So this decimal right here would be our percent decrease. And so obviously right now it's written as a decimal, so that would just be as a percentage 8%. So we would say that this car is decreasing in value approximately 8% each year, which typically is what happens with vehicles. All right, number two, in 2000, the population of a city was about 1.04 million. During the next 14 years, the population increased by about 2.05% each year. And we want to write an exponential growth model giving the population y in millions t years after 2000 and estimate the population in 2008. So we're kind of going to do two things here. So we noticed that in 2000, we had a starting population of 1.04 million, so y equals 1.04. Now it says the population increased by 2.05% each year. So in here, remember we're going to do 1 plus r, and we're going to raise that to the t. So we need to write 2.05% as a decimal. So that's going to be 0.0205, right? Essentially move that decimal 1, 2 places to the left, and that's what it would give us. So we're going to take this decimal, and we're going to plug it in right there for r. So basically, we're just going to add 1 to it. So our exponential growth model would be y equals 1.04 times 1.0205 to the t. That would be our model. So now to estimate the population in 2008, well, that would be 8 years after. So t would be 8. So we could just type this equation in our calculator, plug in 8 for t, hit enter, and it's going to give us that approximately after 8 years, or I guess we should say in 2008, the population is approximately 1.22 million. Okay, so that would be our two answers for example number 2, and that is how you can write some exponential growth and decay models.